Stuart Chaffee. Sitting in for Gary Kildall this week is Herb Lechner of SRI. Herb, we think of chess as the ultimate game of skill, a game that requires mental agility, intelligence, if you will. Yet here I am playing a game of chess with a computer, which is analyzing board positions and applying a certain kind of intelligence to figure out what its next move should be. That's the subject of our program today, artificial intelligence. And in some people's minds, AI suggests attempting to duplicate the way a human brain works. Is that what AI is, in fact?
Not in most modern AI research, Stuart. Early research in AI looked at duplicating human thought processes, but current AI research is more concerned with duplicating the end result of intelligence. And computers that act as experts in expert systems, and computers that can communicate with us in our language, understanding some of the context of that language, are two areas that are receiving a lot of attention in artificial intelligence research today.
Okay, we're going to meet two of the world's foremost experts on artificial intelligence, and we'll take a look at two fascinating examples of expert systems. One of the leading experts on expert systems is Dr. Edward Feigenbaum of Stanford University. We asked Professor Feigenbaum about the evolution of artificial intelligence.
The computers, as you know, are general symbol processing devices capable of manipulating any kinds of symbols, of which numbers constitute one important class, but computers are much more general than that. We've known about the generality of computation since at least the time of Turing in the 1930s, and actually I've tracked it back to intuitions that Babbage had that were reported by Ada Lovelace, after whom the Ada programming language is named. In 1842, Ada Lovelace wrote that the analytical engine of Babbage's constituted the link between the mechanical world and the world of the most abstract concepts. That currently, in the modern terminology, is called the physical symbol system hypothesis and is the basis for artificial intelligence work. In artificial intelligence as a science, we talk about the use of computers to process symbolic knowledge using logical inference methods, symbolic inference methods. In other words, we're talking about inference and not calculation in the traditional sense. We're talking about knowledge and not numbers in the traditional sense.
A current application of inferential knowledge engineering is in the field of expert systems. Programs like this Oil Exploration Advisor. Developed to assist drilling rigs in remote areas, the program behaves much like a qualified specialist. It asks questions of its user and then gives advice on how to avoid or correct accidents so common in drilling operations. If at some point in the line of questioning the user becomes confused by the query, he can ask the program to explain itself, simply by entering why. The advisor responds with a specific source behind the question and explains its reasoning up to that point. The symbolic processing behind the human-like talents of this program have found applications in a broad range of fields, from medicine to robotics. Perhaps the most difficult area for AI to master has been natural language, a talent that results in very friendly computers, but that requires enormous processing capacity. The ambiguities of syntax and context have restricted present systems to very limited applications. A simple geographic question, depending on the phrasing, can lead to multiple interpretations. The program will determine the question's most likely meaning only after an exhaustive deconstruction of the sentence, and might even reject an unusual phrasing of the same query. In a parallel development, investing AI programs with linguistic ability has led to an interactive study of graphic communication. In this experiment, the visual dynamics of communication form the foundation for a linguistic expert advisor capable not only of discerning visual patterns, but also acting as a kind of tutor. One interactive application has given persons without normal speech the ability to adapt or construct alternative symbolic languages, a remarkable instance of using a computer program's intelligence to help interpret human intelligence.